Hey people, and welcome to this video. So in this video, we will be working on the Mathematics Paper 1, May-June 2026 exam. Okay, so if you want to download this paper, it will also just be in the description below. So you can click the link to download the paper. Okay, so let's get into question 2. Okay, question 2.1 says, given the arithmetic series, we have 6, 10, and 14, okay, and it just keeps going because it's a series. And they tell us which term in the series has the value of 602. So they're asking, which term? So do you see how this is term 1? It has the value of 6. This is term 2. It has the value of 10. Term 3 has the value of 14. They're asking which term has the value of 602. So we will see this as Tn. There is a term that has a value of 602 and we need to find this. They're referring to a term, so you need the general term of this pattern. Okay, so to find the general term of this pattern, which is your formula, you simply just say Tn is equal to, remember it is an arithmetic series, okay? So Tn is equal to, we say A plus n minus 1 times D. And so the value of A, we can see that that is the first term, 6. And then D, the difference. What are we doing each time? From 6 to get to 10, okay, we add by 4. From 10 to 14, add 4. And so our difference is 4. And so this is what we're going to substitute. Remember how we're looking for which term has a value of 602? You're just going to substitute 602 in place of Tn, okay, so you can find the value of n, okay, because that's going to be the term number. And so we have 602 is equal to 6 plus, and then we have n minus 1, then the difference is 4. And you just have to solve for n in this equation. Okay, so I'll start by taking the 6 over, since I can see that we have two terms here. These are together because they're multiplying. And so let's take the 6 over. So if you take 602 and then you say minus 6, okay, that's like saying 600 minus 4, which will give us 596, which is equal to, and then you have 4 times n minus 1, and you're still trying to solve for n. So now we can just get rid of the 4. So divide both hand sides of the equation by 4, and finally, what is 596 divided by 4? That gives us 149. So we'll just say 149 is equal to n minus 1. And then if you take the negative 1 over, that's going to be 149 plus 1. That's what gives you n. And so finally, n is simply equal to 150. And that is our answer. Okay, it's the 150th term that has a value of 602. Moving on to the next question. And then question 2.1.2 says, show that Sn, so the sum of n terms, the sum of the first n terms, is equal to 2n squared plus 4n. Okay, this is an arithmetic series, so its sum formula, Sn, we can, because I don't know what the last term is. I mean, it is even called Sn because we don't know what the last term is. So I'll use this one, n over 2, and then open bracket 2a plus n minus 1 times d. Okay, so the one with d, we can use that. And if we have these values, okay, the value of a and the value of d, we're just going to put that in, which we already have. We know that a is 6 and d is 4. So we're still saying Sn, because they didn't say substitute an n value, is equal to n over 2, and then 2 times 6 plus, and then n minus 1 times d, and we know that the difference is 4. Okay, so this is what we have. And then finally, let's just simplify this. Sn equals, and we're saying n over 2, and this will give us 12. So this is 12. And then these, you see, you can actually write this as 4 times n minus 1. That's really what it is. And so when you distribute, you're just going to get a 4n, so positive 4n, and then minus 4. Okay, so this is what we have. And then Sn is equal to n over 2, and then we have 12 minus 4, which gives us 8. And then this is really just 4n plus 8. Okay, and then you're just going to multiply this n over 2 in. So you see n over 2, you can actually rewrite it like this. Because it's n over 2, there's an invisible 1 in front of the n. And this is just in the numerator. So you could have written it as 1 over 2 n, because this is still in the numerator. It's not in the denominator. It has a natural denominator of 1. And it's next to the half because it's multiplying. And so do you see that if you multiplied it out, it could end up looking like this, as the 1n over 2, which is just n over 2. So we're just going to rewrite that as 1 over 2n, which is a half n. And finally, distribute. So Sn equals, if you multiply in, we're going to get, what's a half times 4? So half of 4 is 2, so that gives you 2. And then n times n is n squared. Then a half n times 8, a half of 8 is 4, and then you have n. And there we go. Okay, so that's all they asked for. Moving on to the next question. The next question, 2.1.3, says calculate the value of, and we have the sum of the series with the general term 4n plus 2. Okay, so that's the formula. But then it starts at n equals 100 and ends at 150. So they want you to find the sum of this series. Okay, we can, I would not expand it. You're only given 2 marks, so why expand? So with this one, what I'm going to do is, let's first think about the type of series that we have. Okay, do you see that the pattern, okay, the formula of the pattern says 4n plus 2. So this is in the form of dn plus c. The minute you see there's something n, okay, and then plus a constant, it just means that this is the difference. This is what each term is going to change by. We're going to keep adding 4 to get to the next term. This is a grade 10, grade 9 way of writing a linear patterns formula. Okay, so you can see it's a linear pattern. So I'm going to think about the 2 types of sum formulas since we're working with sigma, the sum. Okay, 2 types of sum formulas that we have. You know that we have these 2 formulas. Okay, and you can use either one of them. I want to go with the easy one here because, this is just 2 marks. So what I'm going to do is go for this. Even if you went for this, it's still fine because you can easily see the difference. Okay, the difference is this. So yeah, this is still fine. I think this would just be easier for now because with this one, you must still find the last term, which you can find because right now, do you see they tell you that it ends at 150. So to find the last term, all you would need to do is say 4 times 150 and then plus 2, and that will give you your last term. But, just to make this simple, I'm not going to use that. I'm just going to use this because we have everything here. Okay, except for a, of course. So the first thing we would need to find is the value of a, and then we need d, and then we need to know how many terms are we actually adding up together. So these are the 3 things we need. Let's go find them. Okay, let's first talk about n. Okay, so notice how they start at 100 and then they end at 150. This does not mean that they are 150 terms because they started at 100, so it can't be 150 terms. So with this, there is a simple rule that you can use. Whenever you are trying to find out the total number of terms, you can simply take the top number minus the bottom number and then say plus 1. Here is an explanation for why. For example, here, if you had n started at, let's say, 2, right? But it ended at 5. There aren't 5 terms in this pattern because you have a term where n is equal to 2, n is equal to 3, n is equal to 4, and then n is equal to 5. Do you see how there's actually 4 terms in this pattern? Because this is an actual included term. The thing with subtraction is if you just say 5 minus 2, you're not considering that n is equal to 2 is an actual term here. Okay, so this is the reason you say the top number minus the bottom number plus 1. Okay, this will give you 3, then plus 1. Now you can see, yes, it's really 4 terms that we have here. Okay, so just watch out for that. So this is simply going to be 50 plus 1, which gives us 51. So we know n is equal to 51. Okay, 51 terms. And then the value of a. To find a, this is the first term. They told you that this pattern starts where n is equal to 100. So to find the first term, you simply take the formula, you say 4 times, and then in place of n, we substitute 100 and then plus 2. Okay, so that's 400 plus 2, and then a is equal to 402. Okay, and now we need to find d, which you can see because it's written in the form of dn plus c, like the grade 9 and grade 10 form. Okay, and then we can finally just say d is equal to 4, and now we are just going to substitute everything we have. Okay, so let's take our formula and put everything in. We are currently trying to find the sum of these terms. Okay, so the sum of 51 terms is equal to 51 over 2, and then open bracket, 2 multiplied by, and we have 402, and then plus, and we have n minus 1, which is 51 minus 1, multiplied by d, which is 4. Okay, and go ahead and put this on your calculator, and then you'll find the sum of these terms. Okay, and when I substitute, I get 25,602. And that is what it sums up to. That is our answer in that question. Moving on to the next question. The next question, 2.2, says, the first 4 terms of a quadratic number pattern are, and these are the terms. And they want us to calculate the value of x. Okay, so if they already gave you that these are the first 4 terms, then you're just going to have to use what you know about a quadratic number pattern. A quadratic number pattern has a first difference, okay? And we can find that first difference first. So to find this, you're always going to say the next term minus the previous term. So term 2 minus term 1, this is negative 4x minus negative 1. And then we'll find 11 minus the negative 4x. And then we have the 2x plus 12 minus the 11. Okay, so you can see that the first difference, there are 3 terms in the first difference. Okay, these terms are not equal to each other. These are just the first differences that we have. Okay, so if you just simplified those, they will simply become, we have negative 4x, that would just be a plus 1. And then we have an 11, and that's just going to become a plus 4x, which we can write as 4x plus 11. And then we have here 2x, and then 12 minus 11 is 1, so plus 1. So these are the first 3 terms in the first difference. Then the second difference. Here's the thing about the second difference, okay, in a quadratic pattern. Remember that the second difference is constant. It's going to be exactly the same all through. So even if I say this term minus this term, it's going to be exactly equal to this term minus this term, okay? So let's find that. We'll just say this is 4x plus 11 minus, and then here we have a negative 4x plus 1. And we know that this should be exactly equal to, here, next term minus the previous term, that is 2x plus 1 minus 4x plus 11. Okay, and this is our equation. We just need to solve for x in this equation. Okay, so this is what we have, and we're just solving for x. So this is 4x plus 11, then that becomes a positive 4x, and a negative 1 is equal to 2x plus 1, then minus 4x minus 11. Okay, simplify the left and the right hand side just to avoid any confusion. So we have 8x, and then 11 minus 1 is positive 10 is equal to, and then here we're going to have a negative 2x, and then 1 minus 11 is negative 10. Okay, now transpose. So we have the 8x, the 2x comes over the negative, okay, it becomes positive, and then we have 10x here is equal to, and here we have a negative 10. This positive 10 comes over to become a negative, so we have negative 20. Then finally, just divide both hand sides of this equation by 10 to solve for x, and x is equal to negative 2, and that is our answer. Okay, moving on to the next question. Then question 2.2.2 says, if x is equal to negative 2, okay, like we can see it is, show that, and you need to find the general term of this quadratic number pattern. Okay, so let's just focus on the things that we need. You know that when they give you your pattern, to find the general term, okay, we always take the first 3 terms of each of these patterns. The quadratic pattern, then the first difference, and then the constant difference. So that's what we're going to focus on, these 3, okay? And then you're going to equate them to the following. So the constant difference, you're going to make that equal to 2a, remember? And then this one, you make it equal to 3a plus b. 3a plus b, and then this one finally, that's going to be equal to a plus b plus c. So I'm only going to find whatever I need. So that, and, all of that. But then again, do remember that, we did simplify this to 8x plus 10. So we can just use that as our difference, okay? So that was this side. And so I'm just going to say the constant difference, right? That was equal to, or just say 2a is equal to, and that was 8x plus 10. But we now know that x is equal to negative 2. So that's negative 2 plus 10. And then you just solve for a in this equation. So 2a is equal to, we have negative 16 plus 10. Negative 16 plus 10 gives you negative 6. Then divide both hand sides of the equation by 2. Finally, a is equal to negative 3. Okay, so there, negative 3 as well. And then we have the b. So 3a plus b equals this. Okay, so I'll just say 3a plus b is equal to, and it's going to be equal to negative 4x plus 1. So negative 4, and then in place of x, we say negative 2 plus 1. Okay, so this is 3, and we know a is negative 3. And plus b equals, that's going to give us a positive 8 plus 1, which is 9. And finally, we'll just say these multiply to become negative 9. And so negative 9 plus b equals 9. B is equal to, we have 9 here. When you transpose this, it becomes a positive 9, and that gives you 18. Okay, so b is 18. Do we have that? Yes. Okay, and then finally c. So that's a plus b plus c equals negative 1. Okay, so just put that down. That's a plus b plus c equals negative 1. We know that a is negative 3, then plus b, which is 18, plus c equals negative 1. And then 18 minus 3 is 15. So this is 15 plus c equals negative 1. C equals negative 1, and take that over. It becomes minus 15. Negative 1 minus 15 is negative 16. Okay, so there we go. Can you also see that it works out perfectly there? Okay, so your formula, and remember it is in the form of a n squared plus b n squared plus c. So therefore we have negative 3n squared plus 18n minus 16, which is really our answer. Moving on to the next question. Question 2.2.3, the last question for question 2, says, consider the first n terms of the quadratic number pattern. Okay, so calculate the least value of n for which the sum of the first differences will be less than negative 1,380. Okay, so at first when you read it, it feels like the focus is on the quadratic number pattern, but it's clearly not, because they're just saying consider the first n terms in the quadratic number pattern so that you know that you are referring to this quadratic pattern. Okay, and then they say calculate the least value, so the smallest value of n for which the sum of the first differences will be less than this. So we're trying to find, okay, it's still a value of n for which the sum of the first differences will be smaller than that value or less than this value. So you're thinking about the sum of the first differences, okay? So this is for the first differences. The first differences is always going to be a linear pattern. So that is these ones here. You have your quadratic pattern here, and then the first differences, these are the first differences, okay? So that's what we're referring to here. So find the value of n for which the sum of these terms will give us a number less than that number, negative 1,380. Okay, so it's still the sum. We're still working on the sum. So we're trying to find the value of n for which Sn is less than, okay, negative 380. But this Sn is referring to the first differences sum. So we need to find that first. Okay, let's just list out the first differences, because right now they're not really complete. So we're just going to have to put them down. So you need to substitute x in place of all of these. Or I mean, you already found the first term. You might as well just use that, and then you can just find what the difference was. Okay, but I'll just deal with this like this. It's no use of doing all of that. We can just say these are our first differences and then substitute x in place of those x values there. So negative 2 is our x value. So let's put that in. Okay, so the first one, you see how that will give you positive 8 plus 1, which is 9. So we know the first term is 9. And then this gives us negative 8 plus 11, which is the same thing as 11 minus 8, which gives us positive 3. And then the next one is going to be negative 4 plus 1, which is a negative 3. Okay, so if this is our pattern, we just need to find the sum of terms, okay, in this pattern. So with this type of pattern, it's a linear pattern, we know that, but let's just find out what exactly that difference is. Because remember, you're still working with Sn. Like in the previous question, we did work with Sn, the sum of terms of an arithmetic pattern. And you saw that we had two types of formulas, okay? So that was up here, okay? Two formulas that we had. And then I ended up going up with this one, okay? I went with this. And with this case, I would also go with that same formula again because I don't actually know what the last term is. They didn't tell us that. So let's go with this formula. We know Sn is equal to, and I'll put it down, okay? And so we're just saying, find the sum of these terms, which would be less than this number. Okay, so we have the value of A in this linear pattern. Okay, the first difference is our linear pattern. So the value of A here is 9. And do we have the value of D? Okay, so the value of D, we're just going to say, how did we get from 9 to 3? You must have said 9 minus 6 to get to 3. And then, how did you get from 3 to negative 3? Well, 3 minus 6 is also negative 3. Okay, so minus 6. So you can see that your constant difference is negative 6. Okay, so D equals negative 6. And we're just saying the sum of these terms must be less than this number. So let's go ahead and put that in. So n, that's just going to be n because we're trying to find n. And then 2a, a is 9. And then plus, and we have n minus 1 multiplied by d, which is negative 6. This needs to be less than negative 1380. And you're just solving for this inequality. Okay, let's try to solve. With this n over 2, I'm going to call it 1 over 2n, like we did in the previous question, just so that it can nicely multiply. And then we have 2 times 9 here, which is 18. And then I'm going to multiply these ones out. So that will give us a negative 6n and a positive 6, okay, is less than the same number that we have. Okay, then 1 over 2n, and simplify here. We have 18 plus 6, which is 24. Then minus 6n is less than negative 1380. Okay, so at this point, you can distribute in. It's not a problem because this is still going to be quadratic at the end of the day. You can see that. So distribute in. And we get, so a half times 24, that is 12. Okay, half of 24 is 12. So 12n. Then those two multiply to become half of 6 is 3. So this is negative 3n squared because of the n times the n. And then you see you still have this. You might as well just bring it over to the left-hand side. So it becomes positive 1380 is less than 0. Okay, so let's just write this so that the values with the highest exponents come first. So we have negative 3n squared, and then positive 12n, then positive 1380 is less than 0. Okay, now all through, do you see that this is a negative 3, this is a 12, and this is a 1380? So let me find out if 1380 can be divided by 3, then I will know, yes, it is a common factor all through. Okay, so we can see that there's a common factor of negative 3 all through. So you can simply divide both hand sides of this by negative 3. Okay, this inequality. And now we have positive n squared. And then we have negative 4n. And then that was 460. Yeah, so negative 460. Then because we are dividing by a negative value, your sign will change to now greater than 0. Okay, so now let's factorize. So open up two brackets, it's greater than 0. And then we're saying n times n, and now we need factors here. Okay, so factors of 460, that can give us a 4. So 460, that can give us a 4. We're going to have to use big numbers here. Let's see, 20. Okay, so if I try 20, 460 divided by 20, 23. So no, not exactly. Let me just see. Let's rather use the quadratic formula because maybe it just can't be factorized. So I'll put down the quadratic formula first. And so you can see that this is the value of A. Okay, it's an invisible 1. And then B is negative 4 and C is negative 460. So let's try this. So negative B, okay, we'll put our bracket. Okay, we'll put our fraction and then negative B. And we have negative 4, okay, plus minus the square root of 4, negative 4 all squared minus 4 AC. So A is 1 and C is negative 460 all over 2A. So 2 times 1. Okay, so yeah, that's probably why. And it's probably why they're saying find the least value of n. Okay, so this is something that we can't really solve by, factorizing, but you'd have to use the quadratic formula. So I'll go ahead and put this calculation in so that we have those. So since this is an inequality, I can just straight away say that I'm trying to find my critical values. Okay, so let's find the critical values. N is equal to, and I'll put down that quadratic formula and all the substitution. Okay, so the first N value we get as a decimal, that is just going to be 23. Well, I can write it as a third first. So that was the 4 square root 29 plus 2. And then we have N is equal to, we can just get that. But let's just put that as a decimal first. That is 23 point. And you can see that it's 5,4. And then there's a 0 after the 4. So it just rounds down to 5,4. Okay. And then here, N, I'll change that to a minus. And now we have N is equal to negative 4 square root 29 plus 2. Okay. So N equals negative 19 point. And again, that also rounds down to 5,4. Okay, so these are our critical values, right? Because it's an inequality, I'll solve for it like an inequality that it is. So we have a quadratic, okay, here. Do you see how if you had to put this on the graph, it's going to draw a parabola. And do you see that the value of A was positive, so it's going to create a concave up parabola or smiley face parabola, okay? And then we can put down our x-axis just like we did in question 1, okay? Then these are the x values we have here. This is on the left, so the negative one will go here. So negative 19.54, that's what goes there. And then the positive one goes here. So this is where N is 23.54. Okay, so the inequality specifically says we need to find the values of N for which this expression is greater than 0. Okay, from question 1, you see that if you're looking for places on the graph where the output or the y values are greater than 0, you're going to look above the x-axis and then less than 0 below the x-axis. So in this case, you're going to take all the parts of the graph that lie above the x-axis. And so this is what we would have. But then I have to stop here. Okay, so here's the thing. This one is negative. Okay, we can't work with a negative. These are term numbers. Okay, term numbers are positional numbers. So they're things like, for example, the first term, speaking about the first position in this pattern. The second term, second position in this pattern. You can't have something like the negative 19th term, okay? Because then you're not really going backwards. Positions move forward, okay? They start from 1 and they move forward. Okay, so I'm not going to use this one. I'm just going to say not applicable and I'm going to leave that. And I'm going to focus on the one with a positive. So do you see that if you have to solve for x here or find the values for which this graph, okay, lies above the x-axis, so this selected section, if you line it down to the x-axis, do you see where these values are pointing? They're pointing towards numbers that are going this way, okay? These are values that are greater than this number, 23.54, okay? So that's what we have there. So as an answer, what I'm saying here is I can see that N is greater than this number. Now, I'm not sure, do they really want this 23.54 or do they want us to write it as this? I mean, it's more understandable like this. Like you can actually see where the number is 23.54. So I'll just write it like this. Okay. And now let's go back to their question because remember, this is an irrational number. Okay. We know that term values also can't be irrational. They are natural numbers like 1, 2, 3. Okay. First term, second term. You can't have the 23.54 term, okay? So let's just see that question again so we can understand. And that's probably why they said the least value. So the question says, we need to calculate the least value of N, meaning the smallest value of N that will be true for this equation, okay? This inequality that we found. So since our answer was N is greater than 23.54, you can think about these numbers on a number line. So if we were looking at the numbers, you'd have 22 and all its 22 points, all those numbers. You have 23, okay? And then you have the 24. Now, 23.54 is maybe somewhere in between, okay? So in between the 23 and the 24. So if this inequality is true for values of N that are simply greater than 23.54, then that would be, if this is 23.54, numbers greater than this would be all the numbers that come here. But remember, we are working with N values. These values cannot be decimals and they also can't be negative. And so the smallest value that would work for this, because you can see that everything here, so infinity, it's always going to work for numbers that are greater than this 23.54. The smallest number that it would work for would be 24, okay? Because it works for 25, 26, 27, every number that goes to the right-hand side, okay? Numbers going here, you would have numbers like 25, and then 26, and then 27, and so on, right? But the smallest number, the least that we would have, would be 24. And so our final answer for n would be n is equal to 24. So if you sum up 24 terms, they will be less than this number. Okay, so that is our answer, and you can also just go ahead and test it out. So here's how you can test it out. You can look at the sum, right? Sn, which is all of this, and then you can substitute n is equal to 24. Okay, so let's try 23 first. So let's try 23 in here, and then let's see the number that we get, and we need to compare to this and make sure that it really is smaller than that number. Okay, let's test that out. Okay, so when I try out 23, I get negative 1311. Okay, so negative 1311. Think about that. Okay, this number negative 1311, is it less than this number negative 1380? No, okay, so 23 does not work. But then immediately you try 24, okay, because remember with negative numbers, the bigger the number looks, the more negative it is, okay, the smaller it is. And so we're going to try out 4. If you put in 4 there, then look at that, okay, there, this number really is less than this number. Okay, so the first number or the smallest value that would work for this, okay, that is true for this inequality would be 24. And that is our answer there. Moving on to the next question. Okay, we are now on question 3. And question 3 says, 2 clocks, A and B, were observed from 9 in the morning, okay, to 10, still in the morning. Okay, so just from 9 to 10. The following observations were made. The time on both clocks was exactly 9 o'clock. And then they say clock A measured time correctly from 9 to 10. So it measured, so the clock A works normally, like a normal clock, okay? And then clock B measured half the time that clock A measured in the first 5 minutes. Okay, I'm going to have to put this down as a table. But then they say thereafter, for every 5 minutes, clock B measured 50% of the time it measured in the previous 5 minutes. Okay, so here's what we have. We have these 2 clocks. Clock A is just like a normal clock. It's working perfectly, you know, moving minute, second by second and minute by minute, okay? And then there's clock B. But then they say clock B is going to measure half the time that clock A measures in the first 5 minutes. So with clock A, in the first 5 minutes, so this is 5 minutes, what clock B does is it measures half of what clock A has measured. So clock A measured 5 minutes, clock B is going to measure 2.5 minutes or 2 minutes, 30 seconds, but we'll just say 2.5. Okay, so we know that that measures 5 minutes, but this one, I kind of want to keep them in line because they are measuring it 5 minutes at a time. So I'll just keep them in line, but I know that this one is going to measure half of 5, so 5/2, okay? 5/2 minutes that it measures. And then you see how they say thereafter, for every 5 minutes, clock B measured 50% of the time it measured in the previous 5 minutes. So this pattern just continues. Clock B is now going to every 5 minutes, whatever it measured in the previous 5 minutes, okay? It's going to measure half of this. So this is 5/2. Then it's going to take a half of 5/2. And then in the next 5 minutes, it's going to take a half of whatever this is. So do you see how that creates, you get in a half of the previous term, half of the previous term. That creates a geometric series, okay, or sequence. Well, I have to call it series in this case because we're working with time, okay? So with time, we're not just counting the minutes that it measured, we're counting what the time is right now, okay? So we still need to count the total minutes that have passed, Okay, I will try to explain that in more detail as we go on. So 5 minutes later, it's going to measure, this one is going to measure half of whatever this is. Okay, so the next total minutes it ends up measuring is half of 5/2. If you say 5/2 and get a half of it times a half, you're going to get 5/4. So it's going to measure 5/4 minutes. And then the next one again, 5 minutes, it's going to measure half of that. So that's going to be times 1/2, which is 5/8, and so on. So this is our pattern. It's just going to be 5/2, 5/4, 5/8, and this continues. Okay, so that's basically what's going on. Now the question 3.1 is, it says, what was the time on clock B when clock A reached 10 o'clock? Okay, so when this reaches 10 o'clock, let's also just fill in the times then. So it starts at 9. They both start at 9. Okay, and then this will eventually, the normal clock eventually reaches 10. Okay, so 10. And now let's see. What would this one reach? So what would the time be on clock B? Well, you can see the way clock B is working. It's not working like a normal clock. It's working as the minutes it's counting creates a geometric series. Okay, so if it creates this kind of series, what ends up happening is each term is going to be smaller than the previous term. So you see that time is just getting shorter and shorter and shorter and shorter, right? So this series is going to be a series that will converge. It's never going to pass a particular time. This clock will never pass a certain time. So we'll still have to find out what exactly that is, if they ask it and stuff. Okay, but let's just focus on the question. So what will be the time on clock B when clock A reaches 10 o'clock? Okay, when clock 10 reaches 10 o'clock, since we are looking in intervals of 5 minutes, because we're only measuring what is going on every 5 minutes, like the real time 5 minutes. So we're going to have to find out how many 5 minutes is it going to take in real time to get to 10 o'clock. And so you can think about that like this. From 9 o'clock to 10 o'clock, there's a total of 60 minutes, right? And since we're trying to find out how many 5 minutes do we have to count to get to 10 o'clock, we'd simply say 60 divided by 5. And I know 60 divided by 5 is 12. So it means it's going to be 12 sets of 5 minutes that we move to get to 10 o'clock. And so we know that this clock, well, if it moves every 5 minutes, it moves by this time every 5 minutes or this time, okay? Then it's going to have to move 12 times to get to 10 o'clock. But of course, it would probably not get to 10 o'clock because you can see the series is converging. There's a number it's not going to pass. Okay, now we're still trying to find out what was the time on clock B, okay, when clock A reaches 10. So let's look at how the time would work. They both start at 9, but then this one moves 2/5 minutes, okay, after 5 minutes in real time. So that's the same thing as 2.5. Meaning the time here, okay, at this point would be 9:00, okay, so 09:02 basically, right? And then in the next 5 minutes, because this clock is only going to move 5/4 minutes, you can find out what 5/4 is. 5/4 minutes, okay, it's just going to be 1.25. So that's just 1 minute and then, a quarter of a minute. Okay, so that will be around 9:03, okay, around there, because it's just going to be plus 1.25 and so on. So it's going to be almost at 4, okay, or almost at 9:04, but then, not quite there. So you see how these work, okay? You're always going to add whatever minutes has passed to the next time. So from 9, then 2.5 minutes passed. So we added it and it's about 9:02. So with time, you need to add these minutes so that you can find out how much minutes in total passed. So what we know now is we're going to have to move 12 times, okay? But then these minutes, we need to add them to finally find out how much it's going to be by the time we have moved 12 times. Okay, so an easier way to do this would not be to measure it just like this. This will take long, okay? Instead of looking at those and it's just going to confuse you, what you're going to end up doing is you're just going to take the minutes that have passed and you're going to add them. So we know that from 9 o'clock, 5 over 2 minutes pass, and then 5 over 4 minutes, then 5 over 8 minutes. Do you see that these minutes need to be added? So this is going to create a series. Okay, so we're trying to find out if this is our pattern, 5 over 2 plus 5 over 4 plus 5 over 8, and this will keep going because we see that we just keep multiplying the previous term by a half. That already tells you what your ratio is. Then we need to find out what this adds up to when we move 12 times. Okay, because from 9 to 10 o'clock, if you're moving in intervals of 5 minutes, you need to move 12 times. 60 minutes divided by 5 is 12. Okay, so what we're just trying to find is the sum of this series, but up until 12 terms. Okay, so yeah, that's really what we're doing here. Okay, so I know that the total number of terms is 12, but let's just put down the series formula. Remember that each time you go to the next term, it's always half of the previous term. So what we keep multiplying by is a half. Our constant ratio is a half, okay? Then this times a half is what gives you our next term, and so on. So we know that the constant ratio R is equal to a half. We know that the total number of terms is 12. And we can also see the first term. The first term is 5 over 2. I'm going to have to take that as the first term because, the first 5 minutes, then this one moves half of whatever that moved. Okay, so A is equal to 5 over 2. And now we can find the sum of this series because we need to find the total minutes that have passed from 9 o'clock, and then we'll add on there and we'll be able to see what the time is at that time. Okay, so this is a sum of the series, but the ratio is a half, okay? The ratio is less than 1. So I'll use this formula. Sn is equal to A times 1 minus R raised to the power of n, and then all over 1 minus R. And so I'm saying the sum of 12 terms is equal to, A value is 5 over 2, and we have 1 minus our ratio is a half, raised to the power of, and then we have 12 there, and then all over 1 minus our ratio of a half, and let's find the sum of the 12 terms in this pattern. Okay, so when we move 12 times, then you can see that the total minutes that have passed is 4.998779, and you can see how this number, okay, if you just round it off, it's close to 5. Okay, so after 12 intervals, which is really just 12 sets of 5 minutes, that have passed in real life, okay, because the clock A is working normally. Then in clock B, the total time that would have passed here would have been, not time that would have passed, but the total minutes that it would have counted would be around 5 minutes. Okay, so I'm just going to say approximately 5 minutes. And so the question was, what is going to be the time? Okay, what is the time on clock B when clock A reaches 10? So the time on clock B would be 09 and only 5 minutes passed. So it's 09:05. Okay, because from 9 o'clock, if only around 5 minutes passed, then it's just going to be 9:05, and that's the time. Okay, so there we go. I'm just going to conclude like that. And that is our answer for that question. Moving on to the next question. And then question 3.2 says, how long will it take clock B to reach the time of 9:06? Justify your answer. Okay, so how long will it take? It took around 5 minutes to reach this, and honestly, it's not even exactly there. It's just like it's so close to it. From the way this number looks, because it's so close to this is where it's probably converging. Well, the thing about this, you can already see where it's going to converge. If this, right, is 5 over 2, which is 2.5, then if this is a series and each term is just half of whatever the previous term is, then it means that every term after this, if you add them all up together, they will equal the first term. That's exactly what it's going to be. It's going to be 2.5. If you add every single term, like the sum to infinity, it's going to be equal to the first term. Okay, but let's still just go ahead and try it out for ourselves. So just to show you that it's definitely going to converge and the time is going to get closer and closer to 5 minutes, but it's never going to pass this. Let's go ahead and try this. Okay, so here we try to find out what the sum of the terms till the 12th term will be. Or in this case, we were trying to find out what the time on clock B would be at the 12th interval. Let's try the 13th interval, okay? So let's say 5 minutes extra pass. Just see what will happen. If you try 13, look at that. 4.999. If you try 14, look at that. It's never going to pass 5. So from this, you can already see it's converging. And so, looking at this question, since they say, how long will it take to reach 906? We know it won't pass 905. So it's never going to pass 906. But the way you can show them this, because you want to show them it will never reach this, you need to show them that this is a series which converges and it's never going to pass 5 minutes, okay? The sum of the series will never pass 5. Or in other words, when you're adding all these times up together, their total will never go past 5 minutes. Okay, so the way to do that is you can just show them the sum to infinity because we can see it's converging and it never passes 5 minutes. So if we were counting that clock's time infinitely, okay, you just kept on going 5 minutes and then 5 minutes till forever, then this is what this is going to look like. We'll say the sum to infinity is equal to a over 1 minus r. We already have the value of a, okay, that is 5 over 2, first term, and then 1 minus, and our constant ratio was a half. Then you can go ahead and put this on your calculator, and you will see that this infinite geometric series, its sum total, okay, is going to be 5. You're never going to go past 5. Okay, and there we go. So it is 5. Because the sum to infinity is 5, you know that the highest time, okay, that clock could ever reach, well, it's never going to. The thing about this, we say it reaches 5 minutes, but like technically, if you had to look at it like on a world clock, it's not really reaching that. But yeah, we can just say approximately 5 minutes. So at the end of the day, the time that it's going to move closer and closer to is 5 minutes. Okay, the maximum it could ever reach, if you're looking at it on a clock, is 5 minutes. So it definitely cannot reach 6. Okay, so in my conclusion, I'm just going to say clock B will never reach 906 since the total time it covers gets infinitely closer to 5 minutes. Okay, so that's what I'm going to leave. There's my answer. So that is it for this question. And that wraps it up for the sequences and series section of this paper. And I will see you guys in functions.